Good morning, students. Today I'm going to give you a PowerPoint presentation on the topic of turning effect of forces in the subject of physics O levels. So concentrate yourself. We are going to start. The turning effect of a force, also known as movement of a force. The movement of a force about any point is defined as force multiplied by perpendicular distance from the turning point to the line of the action of the force. So this is the distance between turning point and the line of the action of the force. So this distance d is called perpendicular distance, and here is the force. So movement is here and force is represented by F and perpendicular distance is represented by D. Unit of the movement will be Newton meters, represented by capital N, small m. Movements can be either clockwise or anti-clockwise. So clockwise is this direction and anti-clockwise is this direction. Force F exerting an anti-clockwise movement through the spanner on the nut. So look now, he is actually applying force like this. So this is anti-clockwise movement. He is actually trying to open the bolt. A question is here, calculate the moment exerted with the claw hammer if the person exerts a force of 80 Newton and distance d equals to 25 centimeter. So because the unit of the moment is Newton meter, so first thing that we people are required to do is convert this centimeter unit into meters. And you know there are 100 centimeters in 1 meter. So 25 centimeter will be converted to meters by dividing this value by 100. So look now. Formula for the movement is F multiplied by D. F is 80 Newton and distance D is 25 centimeter. So now we will convert this 25 centimeter into meters by dividing this value by 100. So 25 divided by 100 will make 0.25. 80 Newton remains same. So now multiply these two values on the calculator. You will get an answer of 20. Unit will be Newton meter. We have to give the direction of the movement as well. So look now, because force is exerting in this direction and this is actually clockwise direction. So 20 Newton meter clockwise. Here is a table that is required to be complete. Force is 40 Newton, distance is 3 meters. So unit are already in standard form. Requirement is movement. So movement is equal to force multiplied by distance. So 40 multiplied by 3 will be equal to 120 Newton meter. So here will be 120. So look now, this is the answer of the first part. In second part, force 200 Newton and movement 1000 Newton meter is given and requirement is distance. So formula used will be movement is equal to force multiplied by distance. So to find the distance, this force will be divided by 1000. So 1000 divided by 200 will be equal to 5. So 5 meter will be the answer. In third part, force is the requirement, distance and movement is given. So again, movement is equal to force multiplied by distance. So to find the force, we have to divide movement by distance. So 200 divided by 4 will be equal to 50. So 50 Newton will be the force. In fourth part, force and distance is given, but the only thing that we have to be careful about, distance is in centimeter given. So first we have to convert this centimeter into meters. So divide this value by 100 and then multiply these two values. So the answer will be 600. So 600 Newton meter will be the answer. So this is the completed table now. Here is another question. Choose appropriate words to fill in the gaps below. Here are some words given and here are some fill in the blanks given. So we are going to start. The moment of a force is another name for the turning effect of a force. From the word this is turning will come here. The second line is the moment of a force is equal to multiplied by the perpendicular distance. Okay, here will come force multiplied by the perpendicular distance. So force, distance. So here is force and here is distance. So look now, between the line of dash of the force, between the line of action. So action will come here of the force and the turning point. Next is turning effect is measured in Newton meters. So this word Newton will come here. Next is dash can be either clockwise or anti-clockwise. So movements can be either clockwise and anti-clockwise. So this is the question. The next is center of mass. The center of mass of a body is that point at which the mass of the body may be thought to be concentrated. This is the definition of the center of the mass. The center of the mass of a symmetrical body is along the axis of the symmetry. The line of the symmetry is a line. When we draw a line of the symmetry at a symmetrical body, when we overlap the object along the line of the symmetry, the two parts overlap at each other. That is actually the line of the symmetry. So look now, the center of the mass of a symmetrical body is along the axis of the symmetry. Here are symmetrical bodies. So if we draw the line of the symmetry from here to here, we draw the diagonals in this rectangle. So that point of intersection of the line of the symmetries will be center of gravity, like this. Look, this is the center of the mass. In this point here will be the center of the mass, because this is a circle. This is the center of the mass. In this body, if we draw the line of the symmetry, join this point with the center of this point, that will be the line of the symmetry. Then draw this line of symmetry and this line of symmetry. So the point of the intersection of the line of symmetries will be center of the mass. If suspended, a body will come to rest with its center of mass directly below the point of the suspension. This is very important point. When we suspend a body and it comes to rest with its center of mass directly below the point of the suspension. This is the point of suspension, and the center of the mass will become exactly below the point of the suspension. Finding the center of the mass of a card. So we are going to find the center of the mass of a irregular body. So look now, what will be the method? Pierce the card in at least two places. So suspend the card from one of these holes like this. The card is suspended from one of the holes on the stand. Hang a plumb line from the point of the suspension. Plumb line is a string with a small weight on the end. So hang the plumb line like this. Using the plumb line as a reference, draw a vertical line on the card. So look now, this vertical line is drawn on the card. Repeat for the other hole. So same procedure will be repeated for the other hole as well. The center of the mass is where the lines cross on the card. So where the lines will cross each other, that point will be called center of the mass of an irregular body. Next topic is the principle of the movement. When an object is not turning, for example, balanced, the total clockwise movement will be equal to total anti-clockwise movement. Student, this is a typing problem, so I'll correct it. This is anti-clockwise movement. So the total clockwise movement will be equal to the total anti-clockwise movement. For example, this is a balanced body. On one end, like on left side of the pivot, a weight is hanging, and on the other side, another weight is hanging. If the ruler above is balanced, clockwise movement should be equal to anti-clockwise movements. That is W2 into D2, like force into distance, should be equal to W1 into D1. So clockwise movement should be equal to anti-clockwise movement when an object is in balanced position. Here is a question. On a seesaw, Mary weighs 600 Newton, balances John, weight 200 Newton when she sits 1.5 meter away from the pivot. So here is the Mary whose weight is 600 Newton and who is sitting at a distance of 1.5 meter away from the pivot, and on the other end is John whose weight is 200 Newton. So the question is, how far from the pivot is John? So if the rod is in balanced position, so the clockwise movements should be equal to anti-clockwise movements. So this is clockwise movement. So John's weight into the distance should be equal to Mary's weight into the distance. So this is anti-clockwise movement. So clockwise movement should be equal to anti-clockwise movement because Mary's weight and distance is given. So 600 into 1.5 will be placed here, and John's weight is 200, and let's suppose the distance is D, will be placed on the right side like this. From here, actually, we are going to find the distance. This 200 will go to the denominator of the left hand side. Solve it on the calculator. You will get the answer, and distance will be in meter because meter unit is used in the question. So here is the answer. Here is another question. Calculate the weight of the beam W0 if it is balanced when, and here are some values. W1 is 6 Newton, so this is 6 Newton, and D1 is 12 centimeter. Its distance from the pivot is given, and weight of the beam distance is given, that is 36 centimeter, and weight W0 is the requirement. Okay, because distance both are given in centimeter, there is no need to convert. If you convert it into meters, that will be more better. But if both values are given in centimeter, because cancellation will be there and answer will be in newtons. So look now, applying the principle of the moment, that is W1, because this is anti-clockwise movement. So first we will write clockwise movements is equal to anti-clockwise movement. So W1 into D1 should be equal to W0 into D0. So now we will apply values in this one. W1, D1 and D0 are given. So these values are going to be placed in the equation like this. Because W0 is the requirement, this 36 will go to the denominator of the left hand side, and then you will solve the values on the calculator. So you will get the answer 2 Newton. Okay, here is another question. Complete for a balanced rule. So an incomplete table is given for the balanced rule. Okay, W1, D1 and W2 are given. So W1 is on left side and W2 is on right side. So clockwise movement should be equal to anti-clockwise movements. So D2 is the requirement. So W2 will divide by these two values. So 10 twos are 20 and 5 twos are 10. So the distance will be 10 centimeters. So look now. In the second part, W1 D1 should be equal to W2 D2. So this will be divided by these two values. So 1.5 into 4 will be equal to 6. 6 Newton will be the answer of W2. In this part also W1 D1 should be equal to W2 D2. So this will be divided by this one. So 6 6 are 6 2s are 12. So here will 12 centimeter. In this part also W1 D1 should be equal to W2 D2. So this will be divided by these two values. So 25 4s are and 4 2s are 8. Here will be 8 Newton. So this is the question. Okay, next topic in the lecture is stability. So look now. These three cases are given. This is a stable, this is balanced, and this is unstable. So look now. A body is stable as long as the line of the action of its weight lies inside the base of the body. So this is the base of the body. So as far as the line of the action of its weight, so here is the line of the action of weight lies within the base, the body will be in stable position. It will come back to its stable position. If we disturb it, if we try to topple it. So as far as the line of the action of the W lies inside the base, the body will be in stable position. So the line of the action of the weight is inside the base, so it will be in stable position. In this position also, still the line of the action of the weight is inside the base, so still it is in balanced position. If it comes outside the base, it will become unstable like this. Here is the line of the action that comes outside the base, so it will be toppled now, that is unstable or toppling. If this is not the case, there will be a resultant movement and the body will tend to topple. What factors make a modern racing car as stable as possible? So remember, there are two conditions for the maximum stability is make the base wider as possible, and number two, the point of the center of the gravity should be as lowered as possible. So more these two conditions will be applied, the more stable will be the body. So listen again. Wider the base and center of the gravity as lower as possible. So look now. What factors make a modern racing car as stable as possible? Because its tires are wider as compared to the ordinary cars. This is the one factor that is making the racing car a very stable. Secondly, if you look at the car, that is almost along the road, so it means its center of gravity is as lower as possible as compared to the ordinary cars. So these are the two factors which are making the racing car a very stable one. So look, a wide wheelbase, a number two, a low center of the mass, that makes the racing car a stable one. Next question is, choose appropriate words to fill in the gaps below. The turning effect of a dash is called, so turning effect of a force. Here is force. So turning effect of a force is also called the movement. Here is the movement. Movement is measured in Newton meters. So here should be Newton. This is the word Newton. If a body is balanced, the total clockwise movement is equal to, should be equal, here is the word equal, to the total anti-clockwise movement. Here is the word anti-clockwise. A body will be dash if the line of the action of its weight lies inside the base. So body will be stable. So here is the word stable inside the base. So here is the word base. A tractor has a large wheel base to reduce the possibility of its toppling. So this is the question. So students, this was the lecture. This was the PowerPoint presentation on the turning effect of forces. Read this question, read this lecture again very carefully, students, and make your notes and learn it. Thank you so much.